guys, welcome to your first ever computer cryptography tutorial. Today we'll be starting with Caesar cipher in 5 steps. So let's get started. Step 1. What are the obvious questions related to this topic? What is Caesar cipher? That is the obvious question, guys. The earliest known use of substitution cipher and the simplest was done by Julius Caesar. So maybe it was used before also, but what we know that this guy is the earliest one. Okay. So the Caesar cipher involves replacing each letter of the alphabet with the letter standing 3 places further down the alphabet. Step 2. What are the requirements? You need a table of reference of numerical equivalent to each letter like this. Okay, so A, B, C all the way up to Z. Okay, or some people call it Z. Anyway, so we represent A by 0, B by 1, C by 2 and so on till Z is equal to 25. So this is because we start from 0 and there are total 26 number of letters, so Z will be 25. Note that the alphabet is wrapped around so that the letter following Z is A. So it's like a cycle, guys. Once you are done after Z, next letter will be A. Okay, so that is step 2. Step 3. How to use this method? The algorithm can be expressed as follows. For each plain text letter P, substitute the ciphertext letter C. Okay, so as I had mentioned in the example above, Caesar cipher, that fellow used 3 letters. So in this example we mentioned about, we shift with 3 positions. So it will be like this. C, that is ciphertext letter, will be encryption of 3, that is the key, comma P. P is the number representative of the plain text letter. Okay, so that will be equal to P plus 3, that is P is the representative number of the plain text, plus 3 mod 26. So for general Caesar algorithm we can shift from 1 to 25 places, so we can call that number K. So it can be any number between 1 to 25. Okay, so for that a general purpose algorithm would be C is equal to E of K comma P, that will be equal to P plus K mod 26. This is step 3. Step 4, guys. How to decrypt? The decryption algorithm is as follows. P, that is the plain text. So this is what is decryption. Decryption is getting the plain text back from your encrypted data. So P, that is plain text, is equal to decryption algorithm of K comma C, where K is the key, guys. So in above case we had mentioned it was 3, and C is the ciphertext letter. So what would be the algorithm for this? C minus K mod 26. So this is step 4. Okay, step 5, guys. Let's solve an example. That's right. So we have taken this plain text, hello world, yo. Okay, second thing what we need is our table for our reference of numerical representatives of this each letter. A is representatives as 0, B as 1, C as 2, Z as 25. This table we had drawn above also, but again I have drawn it so that you can again reference it. Now let's apply the Caesar cipher to the plain text. We will use K is equal to 3 because that's what the Caesar cipher had done. So we will use K is equal to 3. Let's perform encryption first. Okay, so C is equal to, as we had seen, it was encryption of 3 comma P, and P is the letter of the plain text, so it will be equal to P plus 3 mod 26. First letter in our plain text is H, as you can see over here, hello, so H. Okay, so it would be, whose representative number is 7. H, you can see it is 7. Okay, so the ciphertext letter of H would be encryption of 3 comma 7, that is 7 plus 3 mod 26, that is C is equal to 10 mod 26. And you know, when you're finding mod, the remainder is what we want. Okay, so 10 mod 26, the remainder is 10 because you cannot divide, because 26 is again bigger than 10. Okay, so the remainder is 10. Now 10 is representative of number K. We can see over here 10 is representative of K. So C for H, or ciphertext for H, is letter K. Okay, similarly for E letter, what we get? E letter, let's see, E is at number 4 position over here, and what we have to do, we have to add 3 because that is the key. You have to add 3, so 4 plus 3 it would be 7, that is H mod 26. Again 26 is bigger than 7, so the answer is 7. So what is 7? 7 is H. Okay, so that's what here we do. 4 plus 3 mod 26, that is 7 mod 26. Answer is 7, and the letter, that is cipher letter, is H. Okay, now I will also show you guys what happens if it is suppose a letter like Y or Z. Okay, what happens at that time? So let's say Y is the representative of number 24 over here. See, Y is the representative of 24 number over here, or 24 is the number, representative number of Y. What we can do is C is equal to E of 3 comma 24, that is encryption function, that is equal to 24 plus 3 mod 26, that is ciphertext letter would be 27 mod 26. Now 27 mod 26, that is remainder when you divide 27 by 26 is 1, and what does 1 represent? B. That's right guys. So let's see over here, B. So that is the ciphertext letter for our Y. Okay, so the final ciphertext of the above plain text would be like this. Hello world yo would look like this after encryption. KHOORZRUOGBR. Okay, now we will see the decryption process guys. You can check this out guys by yourself. Solving this problem is very easy. You can solve, and if you have any trouble, please ask them in the comment section below. Don't forget to subscribe. Now we'll see how we do the decryption process. What is the algorithm we had seen for decryption? Plain text can be achieved by C minus K mod 26. What is C? C is the ciphertext, K is the key, okay, and our key is 3. So what we do? We perform the decryption like this. P is equal to D of 3 comma 10. Now 3 is the key and 10 is our first ciphertext letter, that is K. You can see over here K is represented by number 10. Okay, so how does it work? 10 minus 3 mod 26, that is 7 mod 26, that is 7. So the plain text recovered after decryption for K is H. Okay, for the second letter it would be 3, that is key, and 7, that is H. Okay, that is 7 minus 3 mod 26, that is 4 mod 26. So we get letter E. So again we are getting over here, this is ciphertext K, we got H. From here H we got E. From O we got L. So similarly we can decrypt everything over here and we get our original text back deciphered. That's it guys for today. This is how we use and perform ciphertext Caesar cipher. If you have any queries, any doubts, please ask them in the comment section below. If you like this video, please hit that like button guys. Please subscribe to the channel. I'll be making more videos on computer cryptography and also computer graphics. So if you like this video, please hit that like button. See you in the next one. Thanks.